Hi everyone, so in this video we will discuss about this subtopic under double integral over non-rectangular region, which is reverse the order of integration. As mentioned earlier, there are two types of integral such as type 1 or type 2 integral. Type 1 is by having as what has been written on the notes such as dy dx. Meanwhile, for type 2 integral, it will be having dx dy instead. When we try to solve, as mentioned in the previous videos, I tried to provide two methods to solve the same question. You will see that even though the two methods will produce the same answer, but the setup will be somehow different, such as the limits will be different from one setup to another. So when you have this type of question, we just want to make sure whether you understand on how to change from type 1 integral to type 2 integral. We just want to test whether you understand the procedures from type 1 to type 2. So basically, as long as you get the facts right on how to solve the problem, it shouldn't be any difficulties when you try to solve this problem. So let's take a look at this example. Normally, we will give you this kind of question and then we never ask you to solve the whole answer. We just want to make sure whether you know or not how to rewrite the limits from type 1 to type 2 integral. So let's move on to this example. Example 4.3.2.1. Okay, you have been given, for A, you have been given with this set up 0, 1 minus 1 over 2x, and 0 until 2 for function fxy dy dx. Okay, right now the question asks you to reverse the order of integration from type 1 integral to type 2 integral. So how to solve? So basically, when you have this type of question, you should be able to illustrate the region R based on the limit given to you in the question. Again, this limit R will help us a lot in terms of to reverse the order of integration from type 1 to type 2 integral. So again, this region R always lies in two-dimensional coordinate system that involve y and x axis. If you look carefully, as if you will need to have an arrow, and this arrow should be bottom up and parallel to y axis. So according to this arrow, you will see that the lower limit with respect to variable y, it will touch y is equal to 0 first, and the best y is equal to 0 will be lies on x-axis. Okay, so this is y equal to 0, and then right after that it will touch, okay, it will touch y is equal to 1 minus 1 over 2 x. Okay, you can try to rewrite the equation. Okay, so you will get what? So if you try to rewrite the equation, you will get y is equal to 2 minus x over 2, 2y is equal to 2 minus x, and 2y plus x equal to 2. By right, this is the general form of equation that represent a straight line. So from this general equation of a straight line, you will standard form of equation of a straight line, you can determine the x-intercept and y-intercept to construct a straight line. So if you look carefully to this equation, you will see that y-intercept is equal to 1 when you let x is equal to 0. So y is equal to 1 and x is equal to 2 is the x-intercept when you set y is equal to 0, then you will end up with this curve. Okay, so the value here is 2, and then it will follow accordingly to limits with respect to variable x. Indeed, it is true, x will travel from x is equal to 0 until x is equal to 2, and this should be your region R. So at this point of time, when you try to answer this type of question, you should be able to illustrate the region R based on the limits given in the question. Before this, we try to compute the limit. Right now, the limit has been given to us, so we have to work on the limit to sketch the region R, which is quite a reverse process compared to what you familiar to in the previous question, in the previous section. Okay, so right now the idea is that you have to come out with double integral, but instead of dy dx, which is type 1, you have to be able to write it in terms of type 2 integral, such as dx dy. So I'm going to use this as your, so instead of having an arrow bottom up, so you should have an arrow which is parallel to x-axis from left to the right. So according to your pink arrow, your curve, your arrow will touch curve that lies on y-axis first. And again, I have to remind you, if the integration is with respect to variable x, therefore the limits belong to variable x, and x should be the subject of your equation. And the best equation to represent line on y-axis is x is equal to 0. And then right after that, according to your observation, the pink arrow will touch the straight line that has been represented by this equation, such as 2y plus x is equal to 2. And again, you have to make sure x is the subject of your equation. Based on this equation, by letting x as the subject of your equation, you will get 2 minus 2y as the upper limit with respect to variable x. What should I do after this? I have to remember, I have to observe this region R along y-axis so that it can cover this region R. In order to cover region R, y should start at y is equal to 0, and it will be the lower limit with respect to variable y, and the upper limit with respect to variable y is as simple as 1. Therefore, this should be the way to answer this type of problem. So I hope maybe you can pause somewhere so that you get an idea on how to solve this problem. If you see in the previous, if you watch in the previous videos, I have mentioned on how to solve the same problem by using two methods, either by using type 1 or type 2. As long as you get the idea there, it shouldn't be any problems when you go through this lesson about reverse the order of the integration. So let's take a look on example B. Example B given to you as double integral y squared until y and 0 until 1 for function fxy dx dy. Again, this question never asks you to solve the question because for function fxy it is unknown, so you cannot solve the problem. So we just want to test whether you know or not how to transform from type 1 integral to type 2 integral, even though eventually it will give you the same answer, but the arrangement will be quite different in terms of limits. Okay, so right now what should I do? I have to be clear with the question given to me, which is the question asked me to express the integral as an equivalent integral with the order of integration reverse, which is if the question asks me, or if the question give me in terms of type 2 integral, which is in this case, I have to be able to rewrite it into type 1 integral. Okay, so right now what should I do? I have to be able to sketch the region R based on the limit given to me. So in this case, I should know that at this point of time, the region R always lies on xy plane on two-dimensional coordinate system that involve x and y axis. Okay, according to our information, we have to sketch an arrow, and this arrow should be sketched parallel to x-axis from left to the right. So in this case, according to this arrow, it will touch x is equal to y squared first. So you have to be able to relate with all the information that you have obtained starting from chapter 1. So according to your knowledge, x is equal to y squared will give you a parabola, and this parabola will give you that will looks like a C shape. Therefore, I will use this color, so you will see this shape first, and then you will see x is equal to y. X is equal to y will give you a straight line. Therefore, you will end up with a straight line. Okay, so right after that, you have to remember the lower and upper limit with respect to variable y. So you have to observe along y axis. So it should give you something. It should start at y is equal to 0, and then it will end at y is equal to 1. So this will be your region R. Okay, so right after we managed to sketch the region R based on the limits given in the question, now we move on to the next process, such as you have to rewrite it from type 2 integral to type 1 integral. So I have to set up my double integral for function fxy. Instead of dx dy, it should be dy dx. So according to my understanding, I have to have an arrow, and this arrow should be parallel to y axis. It moves bottom up. So according to this orange arrow, so it will touch the straight line first, which is represented by x is equal to y, and this has been represented by x is equal to y squared. Okay, so according to this orange arrow, it will touch the straight line. Therefore, the first integral is integration with respect to variable y. Y should be the subject of my equation. Therefore, y is equal to x will be the lower limit with respect to variable y. And then what should I do right after this? This orange arrow will touch the parabola x is equal to y squared. Again, you have to remember, you have to make sure y is the subject of the equation. According to the expression given to us, y is y squared. So you have to get rid of y squared. You will end up having y is equal to plus minus third x. Again, you have plus minus third x. If you look carefully, this parabola, a portion of it lies on the first quadrant, meanwhile the rest of the parabola lies on the fourth quadrant. So according to your logic, the upper part of the parabola should be represented by positive third y, meanwhile this one should be represented by negative third y. We are talking about a portion of parabola that lies on the first quadrant. Therefore, the best equation to represent the portion of the parabola on the first quadrant is positive third y. So right now, since the value here is 1, therefore by using either expression, you will end up with this the same value for x coordinate, which is point of intersection over here. So when y is equal to 1, x is equal to 1, or when y is equal to 1, by using the other equation, x is equal to 1 squared, which is also 1. Therefore, x travel from x is equal to 0 until x is equal to 1. So that's it. You don't have to solve the question, but you have to be able to rewrite it from type 1 to type 2 or from type 2 to type 1. Okay, so right now let's take a look at past semester question, and this question is taken from test 2 2016-2017 semester 1. Okay, so let's take a look at this question where the author asks you to sketch the region R based on the limits given in the question. Okay, so right now what should I do? I have to be certain in terms of the question given to me, which is the question has been written in type 1 integral. So always remember, your region R should always be sketched on y versus x axis. Okay, and then you have to sketch an arrow, and this arrow should be parallel to y axis bottom up. So in this case, according to this arrow, it will come across y is equal to x squared minus 1. So if you still remember, when you have y is equal to x squared, it will give you a parabola. Whenever you have x squared minus 1, your parabola will be moving 1 unit down. So in this case, I will get a parabola that shift 1 unit down, and this one is y is equal to x squared minus 1. Okay, and then maybe you can try to determine the x-intercept and y-intercept of this parabola. Okay, y-intercept is as simple as by letting x is equal to 0, you will get y is equal to negative 1. And then the x-intercept, the intersection point at x-axis can be determined by letting y is equal to 0. Y is equal to 0, x squared minus 1 equal to 0, x squared equal to 1, x equal to plus minus 1. So the value here is x is equal to negative 1 and x is equal to negative, x is equal to 1. So here x is equal to negative 1. Here is y is equal to negative 1. So right now, right after the red arrow come across with the parabola y is equal to x squared minus 1, and then the parabola will touch another curve, which is y is equal to x plus 1, which is, this is actually equation that will produce a straight line. So in order to sketch the straight line, you should find the x and y intercept. So x intercept of this straight line can be obtained by letting y is equal to 0. Therefore, x is equal to negative 1. Y intercept can be obtained by simply letting x is equal to 0, y is equal to 1. Therefore, so here is x is equal to negative 1 and here is y is equal to 1. So I will sketch another line or another curve. Okay, this will be the straight line. Y is equal to x plus 1. Therefore, according to my observation, this should be my region. Before that, right after you manage to sketch these two curves, in order to double confirm with your region R, you have to look at your limits with respect to variable x, which is, it should always start at x is equal to 1 and then it will end at x is equal to 2. So this one is x is equal to 1, so this is x is equal to 2. Therefore, this is your region R. Okay, maybe I have to copy this one so that, okay, so let's take a look at this second question. So reverse the order of integration. So what should I do if I have this question? Again, if the question is written in terms of type 1 integral, the author will ask you to rewrite the double integral setup to type 2 integral. So what will I do here? I will paste the curve that we have sketched above. Okay, so right now what should I do with this question? I have to sketch an arrow from left to the right parallel to x-axis. Okay, the reason why I have these two arrows, basically you can see the difference by using one arrow only, but I just want to show to you that this region R, okay, this region R actually is separated into two separate regions, such as region R1 plus region R2. So let me do some cleaning over here. Okay, this one and also this one. Okay, we call this part as R1 and R2 because by using type 1 integral without separate it into two separate regions, you are able to cover the whole region R. But it will be quite different when it comes to type 2 integral. So you cannot use one region to cover the whole region because it won't cover the whole region. So this is the ideas. It will be quite complicated, you see, because this is the reason why we end up with this question, because we want to make sure whether you are able to differentiate the difference by using type 1 and by using type 2 integral. Okay, so right now if you look carefully, there is a property on topics 4.2 about this kind of problems. Maybe you can reverse, or maybe you can refer to the video on 4.2 so that you can relate with this question. Therefore, you will have this kind of setup: double integral over region R for function fxy. dA is equal to double integral over region R1 function fxy dx dy plus double integral over region R2 for function xy dx dy. Okay, if you insist on solving this question by using only one single region, trust me, you won't cover the whole region R. Okay, because you have to answer the question according to your region. Okay, that's why we separate it into two separate regions. Therefore, what should I do with this question? I have to focus on one region to another region. Okay, so right now, please look at the first arrow. Maybe we can use different color to represent different arrow. So let me do something over here. Okay, please take a look at the red arrow first. Okay, or the first region R1. Okay, so right now, right after this, you will see that you have to have double integral for function fxy dx dy. So hence explain why we have arrow parallel to x-axis moving from left to the right. Okay, based on this red arrow, it will touch the straight line first, and the straight line is represented by that equation y is equal to x plus 1. So you have to remember, the first integral is integration with respect to variable x. Therefore, the limits belong to variable x, and x should be the subject of your equation, which is very easy and straightforward. X is equal to y minus 1 should be the lower limit with respect to variable x in the first region R1. Okay, what should I do right after this? Right after this, you will see that it will touch the green curve that represent parabola y is equal to x squared minus 1. Am I right? Okay, therefore you have to do something with this equation that represent a parabola, because it is written in terms of y, which is y is the subject of your equation. You have to remember x should be the subject of your equation. Maybe you can do something over here. Y is equal to x squared minus 1, y plus 1 equal to x squared. X is equal to y plus 1 set plus minus. Am I right? Okay, if you refer to what has been explained in the previous video, in the previous lesson, this parabola can be separated into two different regions, which is the first a portion of a parabola lies on the first and fourth quadrant, and the second portion of the parabola lies on the first and fourth quadrant. Meanwhile, the second part of the parabola lies on the second and third quadrant. So right now, the best equation to represent the parabola that lies on the first and fourth quadrant is actually plus set y plus 1. Meanwhile, this portion of parabola can be represented by this equation negative y plus 1. So right now, the upper limit with respect to variable x for the first region is set y plus 1. And then the lower and upper limit with respect to variable y. So you look at this value over here. We know already that this value represent x is equal to 2. Therefore, when x is equal to 2, y is equal to, either expression will give the same value for y, which is 2 plus 1, 3. Therefore, x travel from 0 until 3. Oh, not x. I beg to differ my own answer. Y is equal to 0 until 3. So we have settled the first region. Therefore, I will have positive here to indicate region R made up from these two different region R1 and region R2 respectively. So let's take a look at the second region R2. So I will have double integral for function fx y dx dy. Hence, explain why I have an arrow parallel to x axis. So according to this green arrow, this green arrow will touch the left part of the parabola, and the left part of the parabola is represented by negative set y plus 1. Therefore, that will be the lower limit with respect to variable x. And right after that, it will touch the right part of the parabola, which can be represented by positive y plus 1. So this is x is equal to something, x is equal to negative set y plus 1. Right after this, what should I do? I have to determine limits with respect to variable y. Since we know already from y is equal to x squared minus 1, the vertex is at y is equal to negative 1 and x is equal to 0. Negative 1, 0 represent the vertex of this parabola. Or it intersect y axis at y is equal to negative 1. Hence, y is equal to negative 1 will be the lower limit with respect to variable y, and y is equal to 0 will be the upper limit with respect to variable y for the second region R2. Hence, this will be the answer for this problem. Okay, so I really hope you can go through this video once again. Please repeat the video until you can understand the process that I did to solve this problem, because it is quite different, and you know that we always prefer to ask different concept of question during your examination. Please make sure you understand the concept so that you get the idea on how to solve the problem. See you again in another video. Please don't forget to subscribe and leave a comment or like the videos. Thank you so much. Bye.